Click the bell icon to get latest videos from Ekeeda.
Hello friends, welcome back to the subject of Machine Design 1. We are right now learning about the design of various shafts, and today we are going to look at a numerical, of course first part of the numerical, which is based on the power distribution shaft. So let us begin with it. So friends, you can see in the screen the given problem. It says that, of course, we already have seen that power distribution shafts do undergo combined loading. The data is given for us. Of course, the diagram is already provided to us that you can see in the last session, in the formula session, of course. You can see the diameter at pulley C. For your reference, let me show you the diagram also. So this is the given problem for us, where we have been given a shaft on which a gear is mounted at point C, a pulley is mounted at point D, and a pulley is mounted at point E, where point B is also bearing. So these 2 points where the shaft is simply supported. Another thing is, for pulley D and pulley E, the belt positions are already given in the problem, which we are going to look at the later session. With certain angles they are given. Especially at point E, the belts are mounted in horizontal manner, and at point D inclined manner, where the angle is made 30 degree. Of course, in the diagram we can see that afterwards. So this is what the distances between them are given. So the distance between A and C is 250, ahead of which the distance is basically 450. Thereafter the distance between these two remains 500, and ahead of it again it remains the 500. So with this given diagram, let us proceed for the solution part. So let's look at it. The diameter of gear C, of course it's a nominal diameter given, is 250 millimeter, where the pressure angle is 20 degree. It's a given data. The diameter of both the pulleys is equal, and that is 400 millimeter. The power which is transmitted by the gear is 50 kilowatt. The power transmitted by the pulley D is 28 kilowatt, and power transmitted by the pulley E is 22 kilowatt. So they are used for different purposes, and that's why it is called power distribution. The next thing we have been given is the ratio of the tensions, the maximum tension and the minimum tension for both the pulleys is 2.5. We have been given that the rotational speed is of 800 rpm. Of course, this is for the shaft given. We have been given the weights of either pulleys, that is equal to 300 Newton. We have been given the material specification. It is the ISC carbon steel, of course, of grade 45. And we have been given N factor is 1.8. With this given data, we have to design the power distribution shaft. Of course, we have to design its diameter. So at the very first section, let's go for the material properties. To select the material properties, since they are not mentioned properly, we have to refer to the given material. It's a carbon steel of grade 45. So from PSG 1.9, we can figure out the material properties. The yield strength is 360 Newton per millimeter square, and the yield ultimate stress is 670 Newton per millimeter square. So with these values, we have to design the rest of the part. Let us start with the force analysis, which is very important factor in this particular kind of problem. So we know that forces are acting in combination. They are acting differently on gear, differently on C, and differently on D pulley, and differently on E pulley. So let us start with the gear C first. Now we know that on a gear, which is in our case, which is given a spur gear, there are two types of forces acting, a tangential and a radial. So the radial force will act vertically downward, passing through the center of gear, means passing through the center of shaft. And Ft is the tangential force which will act on the shaft in the tangential manner or the eccentric manner. And if Rc is the radius of the shaft, and if this is the way the shaft or the gear is rotating, of course it's a given data, let me mention that this particular direction is given, so that this is the way the converted shaft comes out to be. Let's try to understand it. Radial load passing through this axis. We have shifted this tangential load to the axis, so that an additional couple will act on this particular gear. That means the couple will act on the shaft. So the couple becomes the force into this distance, which is the radius. Of course, this concept we already have learned in the subject of mechanics. Therefore, the torque transmitted We can use this letter or this letter for torque transmitted, doesn't matter. We'll go for this because we have been using uniformly the same letter. So it is the torque transmitted or the torsional moment about point C or at the point C. We know this straightforward formula. We also know the power to be transmitted by the gear is 50 kilowatt. Let's substitute the values. The RPM value let us substitute, which is 800 of course. Upon solving, we'll get the value of torsional moment acting at point C in terms of Newton millimeter is somewhere around 60 kilonewton meter. So that is what the value we have. So let us move ahead with the force analysis for the next component, that is our pulley D. And therefore the value again let us write down. Let's wind it out to make a perfect value. But we know that the torque is given by the tangential force into the radius, and let's substitute the values. The force Ft is unknown, of course we are doing force analysis for that. The diameter of gear we have been given is 250, so the radius becomes 250 divided by 2, and therefore the value of tangential force acting on the gear comes out to be somewhere around 4700 Newton. Now there is another relation that we already know, that the radial force and the tangential force share between them is tan alpha. We have been given alpha value is 20 degree already. So let us substitute the values back in this and let us get the answer of the radius or the radial force is equal to. So this is what the radial force and the tangential force which is acting on the gear. In all previous problems which we have solved, this analysis was already given to us, so we could use it very effectively for the solving the problem. In this problem we have to do it in separate. The next thing is pulley D. In pulley D, now this is again a given data. In this given data we have been given the direction of the belts which are making certain angle 30 degree with the vertical. We have been given the load of pulley D or the weight of pulley D. So that let us convert it into an equivalent manner, which will give me this particular equation. Let us take the equivalent tension. So that becomes TD1 plus TD2. TD1 plus TD2. So let us say it is TD, the tension in D belt, which is making this angle 60 degree. It's making angle 30 degree with vertical, that's why 60 degree with horizontal. This is the direction of rotation of the pulley, and hence the rotational or torsional moment will be in opposite direction. So let us call it MTD, and also its weight, which in other way will be converted to. It's an inclined component, let us resolve it. We have been given the angle, so it becomes the cos component of the tension and it becomes the sine component of the tension. So all over there are basically three forces or four different forces acting on this given pulley: a horizontal, a vertical, another vertical, and the torsional. Let us find out this value of MTD. We know that the power to be distributed by the pulley D is 28 kilowatt. Now we know that rotational speed for all of them, both pulleys, a gear and the shaft, will be same. Upon solving this, we'll get the value. So this is the torque or torsional moment acting on this particular pulley, and therefore this is what the relation we have. Now the next thing we have is, we know the relationship between these two. That makes it, let's write it down separately. The radii, the diameters we have been given are 400, so radii become 400 divided by 2, but we already know this value, which has come out to be, upon solving this we'll get the value of T2D. So these are the values of respective tensions acting at pulley D. Now it's again a given data, so given directions of the belts are given. Now it's up to us how to decide the tension maximum and minimum. For that, forget about these two tensions right now. Just remember that there are two different tensions going to act on this belt. Now we know that this is the direction of rotation. Since this is the direction of rotation, exactly opposite side will have the maximum tension and the same direction will have the minimum tension. That's why this becomes the maximum tension in pulley E, or the belt which is mounted in pulley E, and the minimum tension in the belt mounted on pulley E. There comes, since this is the rotation direction, there comes the opposite torsional moment acting on pulley E. That's why MTE is acting in the opposite direction. When we go for the equivalency of this particular system, we have got a combination of these two tensions, that is TE, where and there is the self weight of that particular E, ahead of which the power transmitted and MTE relation we have. So the power to be transmitted by the drive E is nothing but, or the pulley E is nothing but 22 kilowatt, solving which will get the answer somewhere around this particular value, Newton millimeter. But again we know that between the torsional moment and the tensions in that particular belt, we have the relation. Now again a relation is given to us, and therefore it becomes the diameters are same again, so the radius. Upon solving this particular expression, we'll get the value, the respective value in tension, the tight side of tension and the slack side of tension. Let me mention that they both are horizontal in manner. So this tension will play an important role whenever we are going to do the horizontal analysis. Of course, they stand for pulley E. So this was the first part where we have figured out the force analysis for all three mountings, the gear, the pulley E and pulley D also. In the next section, we will do the analysis in horizontal and vertical manner, upon which we'll go ahead for the analysis and design of the shaft. Thank you so much for watching this video. If you like this video, please subscribe to Ekeeda. Thank you.